Get ready, because we're gonna dive deep into some seriously mind-bending stuff today. Google's new quantum chip Willow just did something incredible. It solved a problem in under 5 minutes.
Wow.
That would have taken the world's fastest supercomputers 10 septillion years.
Really?
To put that into perspective, we're talking about a time frame that's vastly longer than the entire age of the universe.
That's amazing.
It really is.
And what makes it even more fascinating is that the problem itself, something called random circuit sampling, isn't about solving like a practical task or anything.
Right.
It's more like a benchmark designed to test the limits of quantum computing power.
I see.
Like a drag race for these super advanced machines.
Okay, so it's not like Willow's going to cure cancer or anything, but it's showing us just how powerful this technology could become.
Exactly.
I read that some people are even suggesting that Willow's success provides evidence for...
Wait for it.
The multiverse.
Yes, that's a claim that's been making the rounds.
Right.
And it's certainly a captivating one.
Yeah.
It essentially boils down to the idea that Willow might be harnessing the power of parallel universes to achieve its incredible speed.
Now you have to explain that.
Oh.
How could a computer chip possibly tap into other dimensions?
Well, to understand that, we need to start with the basics of quantum computing.
Okay.
Unlike the computers we use every day that rely on bits, which can be either a 0 or a 1.
Yeah.
Quantum computers use qubits.
Okay.
And here's where it gets interesting.
Right.
Qubits can exist in a state called superposition.
Superposition?
Yeah.
That sounds like something straight out of a superhero comic.
It kind of is.
Okay.
Imagine a coin spinning in the air before it lands.
Yeah.
It's both heads and tails at the same time.
Right.
That's superposition. A qubit can be both a 0 and a 1 simultaneously.
I see.
It's only when we measure it
that
it collapses into one definite state.
Gotcha.
This allows quantum computers to perform calculations in ways that are completely impossible for classical computers.
Okay, I think I'm starting to get it. So because qubits can be in multiple states at once, they can explore many possibilities simultaneously, making them super fast.
Exactly.
But where does the multiverse fit into all of this?
That's where things get really mind-bending.
Okay.
One interpretation of quantum mechanics, known as the many worlds interpretation, suggests that every time a qubit collapses from this state of superposition, a new universe branches off.
Oh, wow.
So in essence, each possible outcome of a quantum measurement is realized in a separate universe.
Okay, so you're saying there could be a universe where I'm a world-famous astronaut and
And
another where I'm a goat herder in the Swiss Alps.
Exactly. In the many worlds interpretation, every possible outcome of every quantum event is playing out in some parallel universe.
That's a lot.
It's a truly dizzying concept.
It is. Okay. I can see where the idea of a quantum computer tapping into other universes is coming from now.
Yeah.
But how do we get from spinning coins and branching universes to Google's Willow chip?
Well, the founder of Google's quantum AI team, Hartmut Neven, has made some pretty bold claims about Willow's performance.
Okay.
He suggests that the chip's speed, its ability to crunch numbers on a timescale that vastly exceeds the age of the universe, lends credence to the multiverse interpretation.
Okay.
He's basically saying that Willow might be tapping into these parallel universes to perform calculations.
That's a pretty big leap.
Yeah.
Is there any actual evidence to support that claim, or is he just speculating?
That's where the debate comes in.
Okay.
While Willow's speed is undoubtedly impressive, many scientists are skeptical of Neven's claims. They argue that there are other interpretations of quantum mechanics that don't require invoking the multiverse.
So there are other ways to explain what Willow is doing?
Absolutely.
Without resorting to parallel universes?
Yes. For example, there's the Copenhagen interpretation, which suggests that the act of observation causes a quantum system to choose one state.
Yeah.
There's also the pilot wave theory, which proposes the existence of hidden variables that guide the behavior of quantum systems.
I see.
These interpretations offer alternative explanations for the weirdness of quantum mechanics without needing to invoke multiple universes.
Okay, so it sounds like there's a lot of debate about whether Willow's performance actually supports the multiverse theory.
Right.
What does that even mean for us if it did? It's not like we can suddenly hop over to a universe where everyone eats pizza for breakfast, lunch, and dinner, right?
Not quite. But The implications of proving the existence of a multiverse would be profound.
Yeah.
Even if we can't physically interact with these other universes.
Right.
It would fundamentally change our understanding of reality itself.
Right.
And raise a whole host of philosophical questions about our place in the grand scheme of things.
Okay, I can definitely see how that would be mind-blowing.
Yeah.
But for now, it seems like the jury is still out on whether Willow is actually cracking open the door to the multiverse.
That's right.
What else is interesting about this chip?
What's truly exciting about Willow, regardless of the multiverse debate, is its potential to revolutionize various fields. One of the biggest challenges in quantum computing has been dealing with errors. Those pesky quantum glitches that can throw off calculations.
Yeah, I see.
Willow has made significant strides in error reduction, meaning it can solve problems more accurately and reliably.
So even if it's not connecting to other universes, Willow is still a major breakthrough.
That's right.
Because it's becoming much more accurate and reliable.
Exactly.
What kind of real-world applications could this lead to?
The possibilities are vast.
Okay.
Imagine being able to design new materials with unprecedented properties, leading to breakthroughs in everything from energy storage to aerospace engineering.
Wow.
Or think about the potential for revolutionizing medicine.
Yeah.
By developing personalized treatments based on an individual's unique genetic makeup.
Wow.
We could even see major advances in artificial intelligence.
Right.
With quantum computers able to process information and learn in ways that are far beyond the capabilities of classical computers.
Wow. It sounds like Willow could have a huge impact on just about every aspect of our lives.
It really could.
It's almost like stepping into a science fiction novel.
It's true.
It really is.
And while some of these applications are still years or even decades away, the progress being made is incredibly exciting.
Yeah.
What's especially fascinating is that quantum computing is forcing us to confront the very limits of our understanding of the universe.
I'm starting to realize that this is about so much more than just building faster computers.
Yeah.
It's about pushing the boundaries of knowledge and exploring the fundamental nature of reality itself.
Precisely.
Yeah.
And even if we never find definitive proof of the multiverse, the journey of exploration is just as valuable as the destination.
I think I'm starting to get a headache from all this mind-bending stuff, but in a good way.
It is a lot to take in.
It is. But before we delve any deeper, though, I think it's time to take a little breather.
Okay.
We'll be back soon to continue our deep dive into the implications of Willow's groundbreaking achievement and what it might tell us about the universe we inhabit.
Sounds good.
Stay tuned. We're back and ready to continue our exploration of quantum computing and the mind-boggling concept of the multiverse.
Yeah.
Before the break, we were talking about how Google's Willow chip, while not definitive proof of the multiverse, that has definitely stirred up the debate. Yeah, it's really highlighted how quantum computing is pushing us to confront the boundaries of our current understanding of reality.
You know, I was thinking about what you said earlier about those different interpretations of quantum mechanics.
Right.
It seems like the multiverse interpretation is just one way of trying to make sense of all the weirdness we see at the quantum level.
That's right. Quantum mechanics has always been full of mind-bending concepts like superposition and entanglement.
Yeah.
These ideas just don't fit neatly into our everyday understanding of the world.
Right.
The many worlds interpretation, which was popularized by physicist David Deutsch, is one attempt to bridge that gap.
So instead of saying that a quantum system randomly chooses a state when we observe it, the many worlds interpretation says that all possible outcomes actually occur.
That's right.
Just in different universes.
Exactly. It's like that choose your own adventure book where every choice creates a new storyline.
That's a great analogy.
Yeah.
And what's fascinating is that quantum computing might actually offer us a way to test some of these mind-bending ideas.
Oh, wow.
It's not about directly observing other universes.
Right.
But rather about seeing how quantum computers behave.
So if we could build a quantum computer powerful enough to do calculations that are impossible for any classical computer, even theoretically, wouldn't that suggest that something really strange is going on? Maybe even hint at the existence of parallel universes.
That's one line of thinking. Of course, it wouldn't be absolute proof.
Right.
but it would be a pretty compelling piece of evidence.
Yeah.
And remember we talked earlier about Shor's algorithm,
Yeah.
a quantum algorithm that could potentially break the encryption we use for online security today.
Right.
A classical computer would take billions of years
Oh, wow.
to factor the large numbers used in modern encryption, right? But a quantum computer using Shor's algorithm could potentially crack it in a practical time frame.
Okay.
That kind of computational power hints at something truly revolutionary happening.
That's amazing. And a bit unsettling if you think about someone being able to break all our online security codes. But I want to get back to the multiverse idea for a moment.
Sure.
Even if we could prove it existed, wouldn't it still be a purely theoretical concept? I mean, it's not like we could actually travel to these other universes, right?
That's right.
Yeah.
At least not with our current understanding of physics.
Right.
The multiverse, even if proven, might remain a concept that we can only explore through theoretical models in the behavior of quantum computers.
So while the debate about Willow and the multiverse is fascinating, it's important to remember that Willow's significance goes far beyond that. We touched on this earlier, but I'd love to dig a bit deeper into the practical applications of this technology. What are some specific areas where Willow's advancements, particularly in error reduction, could lead to real-world breakthroughs?
One area that's particularly exciting is drug discovery.
Okay.
Imagine being able to simulate the interactions of molecules at a quantum level.
Wow.
This could allow us to design drugs with incredible precision, targeting specific diseases with far fewer side effects.
I see.
Willow's improvements in error reduction could make these simulations far more accurate and reliable, accelerating the development of life-saving treatments.
That would be a game changer for so many people.
It really would.
What about other fields? You mentioned materials science earlier.
Yes, material science is another area ripe for disruption.
Okay.
With quantum computers, we could design materials with properties we can only dream of today.
Oh, wow.
Imagine ultra-lightweight, but incredibly strong materials for building spacecraft. Or super-efficient solar panels that capture energy from the sun like never before.
Wow.
These breakthroughs could revolutionize industries and help us address some of the world's most pressing challenges like climate change.
It's amazing to think about all the potential benefits.
It is.
But like with any powerful technology, there are also potential risks, right? How do we ensure that quantum computing is used for good and not for harm?
That's a crucial question. And it's one that we need to address as a society. We need to think about ethical guidelines for the development and use of quantum computers, ensuring that they're not used for malicious purposes, like creating incredibly powerful weapons or invading people's privacy in ways we haven't even imagined.
It sounds like the future of quantum computing is going to be a wild ride.
It really is.
Full of incredible opportunities and some serious challenges. This deep dive has been eye-opening, to say the least.
It has been a fascinating journey, hasn't it?
It really has.
And we've really only just begun to explore the surface of this incredible field.
We've gone from the mind-boggling speed of Google's Willow chip to the philosophical implications of the multiverse and the potential for both good and harm that comes with such a powerful technology. Before we get ahead of ourselves, though, I think it's time for us to pause and reflect on what we've learned so far. We'll be back shortly to wrap things up.
Sounds good.
And consider what this all means for our understanding of the universe and our place within it.
Okay.
Welcome back to our deep dive into the world of quantum computing. It's hard to believe we've only just scratched the surface of this incredible field before the break. We were discussing the potential of Willow and quantum computers like it to revolutionize industries like medicine and material science, while also acknowledging the potential ethical challenges we might face.
It's true. We're standing on the precipice of a technological revolution. And as with any revolution, there will be both incredible opportunities and significant challenges. But before we dive too deeply into those, I want to circle back to a question we posed earlier. One that has captivated philosophers and scientists for centuries. If we could prove the existence of the multiverse, how would that change our understanding of ourselves and the universe?
You really left us hanging with that one before the break. It's a mind-boggling concept, to say the least. If there are countless other universes out there, each with its own set of physical laws and possibilities.
Right.
What does that mean for us here in this reality? Does our existence even matter in the grand scheme of things?
Those are profound questions, and there are no easy answers. The multiverse concept challenges our very notion of reality.
Yeah.
And forces us to confront the limits of our understanding. Imagine for a moment that you could look through a window and see countless other versions of yourself, each living out a different life, making different choices, experiencing different joys and sorrows. What would that do to your sense of self?
It's almost too much to wrap my head around. Would I feel less unique knowing that there are infinite versions of me out there? Or would it be liberating, realizing that there are endless possibilities for who I could be?
It's a paradox, isn't it? On the one hand, the multiverse could make our individual lives seem less significant, just one tiny thread in an infinitely vast tapestry. But on the other hand, it opens up a realm of incredible possibilities, suggesting that anything we can imagine might be happening somewhere out there.
It's enough to make you question the concept of free will if every possible choice is being made by some version of ourselves in a parallel universe.
Right.
Do we really have control over our own destiny?
That's a question philosophers have been grappling with for centuries, and the multiverse concept certainly adds another layer of complexity.
Right.
But even if we can't definitively answer these profound questions, the fact that we're even asking them shows how deeply quantum computing is changing our perspective on the universe and our place within it.
It's definitely a lot to ponder. I think this deep dive has been one of the most mind-expanding experiences I've ever had. We've gone from the incredible speed of Google's Willow chip to the philosophical implications of the multiverse, and we've barely scratched the surface.
It's been an incredible journey. And it's clear that we're just at the beginning of a new era of scientific discovery as quantum computing continues to advance. It's bound to raise even more profound questions about the nature of reality, the limits of knowledge, and the very essence of what it means to exist.
And even if we never find definitive answers to these questions, the act of exploring them, of pushing the boundaries of human understanding, is what makes science so captivating. It's about embracing the unknown, questioning our assumptions, and always being open to new possibilities.
That's beautifully said. And as we wrap up this deep dive, I think it's important to remember that the most important discoveries often lead to more questions than answers.
Yeah.
This is not the end of the journey, but the beginning of a much larger exploration.
Well said. Thank you for joining us on this incredible journey into the mind-bending world of quantum computing and the tantalizing possibility of the multiverse. It's been a privilege to explore these ideas with you.
The pleasure was all mine.
And to our listeners, remember that the nature of reality is still a mystery, and these are questions worth pondering, even if we never get definitive answers. We hope this deep dive has inspired you to continue exploring the universe and all its wonders.
Until next time, keep questioning, keep exploring, and keep diving deep.
That's all for this deep dive. See you next time.